Dear Level 3 students, credit our system, Department of Socio-Computing at the Faculty of Economics and Political Science, Cairo University. Welcome back to our course named Social Network Analysis.
Lecture 19. As usual, let's start with a brief review of dynamic network analysis in general, because we have finished in the previous lecture, which is lecture 18, the final part of dynamic network analysis. So in dynamic network analysis, again, we have 3 questions to answer. If you want to create a dynamic network analysis, the first question is, how do networks evolve? And we said networks evolve through homophily and or diffusion or contagion. The second question is, how can we predict what kind of networks will form with time, or what will be the emergent structure of networks after this evolution would happen? And we studied several kinds of social networks, including random networks, scale-free networks, small world networks, and hybrid networks. And finally, the third question that we have to ask ourselves if we are going to make a dynamic network analysis is, what can we predict, or how can we predict what will happen inside a network? And in this case, we said that inside a network, or given that we have a stable network structure, inside the network, for example, diffusion can be affected with the structure of the network. So if we started with a random network, the diffusion will go with some speed. And if we have a scale-free network, the diffusion will go, or ideas and diseases will spread with much less time. And also, we studied before small world networks 2 or 3 lectures ago. We studied information diffusion in small world networks, and we applied on COVID-19 virus, for example. So we studied 3 different kinds or structures of social networks, and we studied what will happen in information diffusion inside these 3 different kinds of networks. Today we will start to make some applications on dynamic network analysis. Social network analysis actually can help us to better understand and tackle the transnational organized crime and dark networks. These dark networks sustain corruption, money laundering, illicit trafficking, drugs trafficking, for example, or human trafficking, children trafficking, and so on. So social network analysis can help us to better understand the dynamics occurring inside these transnational organized crime in general, and terrorism or terroristic crimes or terror crimes in particular. How can social network analysis help us to understand this special type of crime? This is through answering questions. For example, social network analysis can help us answer some questions like, how dense or closely connected is the network? Is it highly centralized, or is there a lot of activity at the periphery? Is there hubs? What kind of clusters and subgroups exist inside these networks, or these dark networks? Which are the most influential and powerful nodes inside these networks? And do you remember the centrality measures? These different measures will be very important here. Which nodes are acting as brokers, mediating between other elements, for example, or other nodes, for example? Which nodes are supplying information, advice, or professional services to the illicit networks, staying mostly invisible on the periphery? How is the network evolving over time? How this dark network evolves over time? How do information flow and diffuse inside this dark network? And ultimately, which nodes must we target in order to disrupt the network and break it down permanently? These are examples of many questions that social network analysis can help to answer. Without social network analysis, you will not be able to answer these questions correctly or properly. So it's also valuable to look at how criminal networks interact with each other. Social network analysts and researchers use publicly available information such as judicial documents, for example, institutional reports, newspaper articles, along with interviews, questionnaires, and other focus groups, for example, and all these tools social researchers and social network analysts use, because with the use of these tools you can build your network, and using what you have studied in the previous 18 lectures, you can answer these questions, and so you can help the decision maker who is facing or dealing with these kinds of dark networks and these kind of organized transnational crime. So the more information you have, the more clearly you can highlight the main structural characteristics of these criminal and dark networks. So today we will study together like a case study that will help us to understand how network analysis can be beneficial in studying terrorism in general as a particular type of organized transnational crimes, and also how network analysis can be important in combating terrorism. The case study that we are going to deal with today is, we took like an example of terrorist attacks, and in general the most popular terrorist attack is the 9/11 attack. So we will see how the 9/11 attack could be used, or how social network analysis and dynamic network analysis in particular can be used to tackle the data or to analyze the data of 9/11 attacks. So let's go. Okay, I know you studied GAFI or JAFI in details in the sections with teaching assistant Dr. Salsabil, and I know JAFI is very interesting, but today we're gonna take a look at another software. It's called Sentinel Visualizer. But Sentinel Visualizer is not free. GAFI is an open source software, so I prefer you use GAFI for your study purposes, but also we can see other examples of softwares that can be used in order to create dynamic network analysis or social network analysis in general. So we're gonna take a look at Sentinel Visualizer. We have a database here. This database have a lot of information. So I am going to pull up an entity record here. In this case, it is a person. And by the way, this database doesn't have only persons. An entity could be a company, a location, or an organization. But in this case, it is a person, and here we have all the attributes or properties of this person in the upper part here of the screen, and also we have a brief or a description of that person in the lower part of the window or the screen here. And as you see, this person is Muhammad Atta. He was an Egyptian hijacker and one of the ringleaders of the 9/11 attacks. He served as the hijacker pilot of American Airlines Flight 11, which he crashed into the North Tower of the World Trade Center as part of the coordinated attacks. There are other various tabs here in the lower part or the lower half of the screen. As you see, there are other various tabs, and most importantly, the relationships tab. So this tab shows us the relationships that this person has with other people, or other places that he visited, or other organizations that he has worked with. So when I visualize this data, I can see that he has these relationships with other people. You will find their photos here inside the notes. And also I can see his relationships with places, for example, the places that he has visited, and you will find the Earth or the GPS logo in the node, or his relationships with other organizations, for example, companies or organizations he has worked for, and you will find the logo of the organization inside the node. So as you see, this is a personal network of this person. Do you remember what we call this network? What's the name of this network? Yes, an ego network. We call this network an ego network, which means the network of one person. So, for example, if you want to draw the network of your friends on Facebook, just your friends, not friends of friends, just your friends. So you will be located at the middle, and then a link appears between you and your friends. So all your friends will be around you, and you will be the center of the network. So this network is called ego network because it is a network that represents the personal links or social ties for just one person. Returning back to our software, there is a new feature here, which is an interface to Google Earth, where you can map out location specific or date and or date specific information. So if we click here on this new feature, which is a Google Earth feature, and we will see what will happen. As you see, it connects us with Google Earth. So if I use this timeline here, I can actually see movements around the globe of this person. I can also expand the entire timeline to see all the places he visited. I can even expand it over here at the left-hand side and click on those different locations. Now let's get back to Sentinel. We have a feature here that is called a timeline down at the screen, down at the lower part of the screen. So if I can expand this date range, I can, as I move this bar, the bar in blue here, back and forth, we can see how these relationships change over time with other people, places, and organizations. So expanding this timeline and moving this bar back and forth, you can see how the relationships of this person, which is represented by the ego network of this person, how these relationships change over time. And this is the dynamic network analysis that we have studied. So we will see, for example, whether that is different companies that he has worked for, or different people he was associated with time, or different places that he visited with time. I can also see these changes in various ways and on different scales. Now, the most interesting part, I can also expand this person social network. So, for example, if I take one of these nodes and then get his links or the link of this node, and maybe I can take another one here, another node over here, and expand or draw its links as well. Now I'm actually creating a social network from our simple database. So if we have a database of some persons and their relationships or their links with other persons, other organizations, and other locations. So if we started just by one person and then see all the persons inside his network, or all persons he is connected with, and then we get for each person their ego networks also, or their networks, then we will be able to construct and create the overall social network inside this terrorist group. So when I redraw this network, I can easily see the central hub. In this case, because we are working on a terrorist database, the central hub is Osama bin Laden. And I can see these three clusters. Do you remember clusters? I can see these three clusters all connected through this one node, which is Osama bin Laden. I want to ask you now, the node in which Osama bin Laden appears, it is the most central here, but in what measure of centrality? I will not answer this question. I want you to answer, because you will be asked in the exam questions like that. So what kind of centrality, or what measure of centrality that we shall use inside this network to know the most central person? Now we have some features here in tabs at the right hand side of the screen. You see it. One of them is called gradients, where you can see the importance of each entity based on different centrality measures. So, do you remember centrality measures? How many measures of centrality do you remember? And can you list three different centrality measures and tell me which measure is most suitable to study the centrality in which networks? For example, can you give me three different measures and three different applications or examples that each of these measures would be used? Returning back to our software and to the tabs at the right hand side of the Sentinel software, we discussed the gradient tab, and we saw how the gradient tab can be used in order to make gradient colors for nodes based on different centrality measures. Now we have also a shortest path tool. So if I want to choose a node here at the left hand side and another node at the right hand side at the other side of the network, and click on the shortest path button, I can see based on this line how can I get from one node to another till I reach the target node from the source node or the beginner node. Also, there is a feature called All Paths. This feature shows me all the possible paths, or all different ways to get from one node to another. And I can even filter out those nodes that don't have anything to do with those paths. This makes it easier for me to focus on these two nodes and all the possible paths that join them only. So again, that was an overview about how dynamic network analysis and how dynamic social networks can be used to analyze and study terror networks in particular, but in general, organized crime and dark networks in general. So we learned in this lecture how network analysis in general and in particular the dynamic network analysis as a crucial part inside network analysis can be used to understand the complexity or to deal with the complexity underlying crime in general, organized crime, transnational crime, and in particular the terror crime or the terrorism and terroristic groups. Social network analysis and dynamic network analysis can help us to deal with this complexity through answering or finding answers to many questions like who is the most central part of this dark network, which person or which node represents the most central node and central in which meaning or in which regard and so which centrality measure that will be used. So this is the first question here. The second question, which is also very important, what subgroups exist in these networks? And this can be studied using the clustering coefficient and the clusters that can be visually seen through the visualization of network data. Social network analysis can give us a notion about what are the patterns of interactions underlying these terror networks or these dark networks, and how does information flow and how can information spread inside these networks, and what is the speed with which the information will flow and spread inside dark networks. And so, as we said in the previous lecture, we can prohibit it if we want using network measures, or we can accelerate this information flow using also network measures. So it's very important to study network analysis when we are dealing with the complexity underlying the terror networks as a particular kind of organized crime in general. Also, network analysis gives us a notion about what is the overall structure of the network. And as you remember from the previous lectures, we studied different kinds of networks and different structures that networks may evolve to. So this also could help us when we are dealing with terrorism and counterterrorism. And the most important question for any person who is making a counterterrorism research and a counterterrorism act, the most important question here, what are the weak points inside this dark network or this terror network, and how can we divide this network, how can we end this network or weaken this network through the weak points. But we will not be able to identify these weak points except we visualize the network and we make our social network analysis with the measures that we have studied throughout the semester. Thank you.
For any further question or for more communication, please don't be hesitated to contact me on my email on the screen now. And you can also view these lectures on my YouTube channel or the YouTube channel of Cairo University as well. So waiting forward to hear from you soon. Thanks.